So first of all, questions? I look tired? Really? I look that bad? Actually, I am still recovering. I got back from Europe on Sunday. I was supposed to get back at at nighttime, but due to various delays, by the time I got home, it was 1:30 in the morning. Got to bed at 2 in the morning Monday. Then I had to get up at 5 to drive up here yesterday to do campus recruiting. So yeah, I am kind of, yeah, there's bags under my eyes. That's probably why. So yeah, I got to catch up. Yeah. So anyway, all right. So no questions? Okay, well, let me remind you then of an upcoming important date. We have to do one of these. So this is scheduled for October 21, so 2 weeks from tonight. It'll cover basically everything that we'll talk about tonight and next week. Okay. And I'll talk more about this. We'll have a little review next week, but basically it'll be it's going to be in class. You'll have the whole class, so 6:30 to 9:20. It's going to be proctored. The way I'm going to do this one is there's going to be a series of multiple choice questions on this one. Again, it'll cover. I'll go over a little bit more detail next time. But basically, if you've been watching the lectures, showing up at class, everything's going to come right out of the notes we've been discussing in class. Okay, and the homeworks, so it's all that stuff. It's not going to be anything new. It's all material that we've covered. So multiple choice. There'll be some short answer, and there'll be a couple where you have to, go off and do some kind of modeling. We talked about some of these. Did we talk about use cases yet? We did, right? Yeah, use cases. That the video from last week was state machines. We'll talk about some others tonight and next week. But that's kind of what this will be: multiple choice, short answer, and then a few of these. Go develop a use case diagram, a state machine, and again, I'll talk about a few more details next week about we'll just go over it and go through it. What's that? 2 weeks. 2 weeks. October 21st. Next week is fall break. Okay, so we'll still have it on the 21st, right? So that means it'll cover up through tonight, right? Okay. So okay, this fall break is that something? I don't. It's just something that I've been teaching for a long time. I don't remember a fall break.
This one is Monday, Tuesday.
Just Monday, Tuesday? Oh, that's probably why. Normally I teach on Thursday. So okay, so we start a little bit early in the summer. Then probably is why. Okay, so fall break, interesting. All right. So. October 14th is fall break. Okay. So then that makes it a little bit easier. So it's going to be everything up through tonight. And then you'll have 2 weeks to prepare. So we at the end of the class tonight, we'll go back and come back to this and I'll say a little bit more about this. Okay? Yeah, closed book, closed notes. Yeah, this is going to be closed book, closed notes. Yeah, the cheat sheet, I've experimented with that in the past. I've gone away from that. Yeah, someone bringing a little sheet and it's so small you can barely read it. I've done all that in the past, but I don't think you're going to need it. It's not the type of thing where you're going to it's not that type of memorization I'm going to put on the exam. You know, like for example, if I tell you to create a use case diagram or a sequence diagram, you know, yeah, maybe you can draw a little sequence diagram on there to remind you, but I don't think it's going to help you that much anyway. So I usually say no to the cheat sheet, okay? And it's been working successfully that way. So let's try that. No, say no to the cheat sheet, and we'll see how the midterm goes. If we have to think of something different for the final, but I don't think you're going to need it. I've gone away from that in all my classes, and it seems to be working okay. And you're going to have plenty of time. Most students will finish before the class period ends, so that's another indicator to me that people seem to be doing okay with it, and so we'll try that way. I'll come back to this at the end of class tonight. We've got the one thing from last week on this state machines that I posted the lecture online on Blackboard. Were there any questions on that? If you haven't looked at that video from last week on state machines, go look at it, because there's going to be at least one question on the midterm on that, on developing a state machine for something. So actually that lecture from last week has state machines. I think it's got activity diagrams. It had a few kind of UML type modeling approaches. So try to, if you haven't looked at it, definitely go back and view that lecture. Okay, so I'm going to come back to this. I'm going to come back to this at the end of the class. The other thing I will do, I know I'm a little bit behind. I didn't get as much done when I was traveling on grading your outstanding homeworks that I wanted to do. So now that I'm back, I will get caught up on all the homework grading and post some sample solutions. So you'll have a chance to use those also for your studying for the midterm. Okay, so I'll definitely get to that during the course of this week and finish it up on the weekend. So you have all that graded as well, coming up pretty quickly. Okay, so far so good on this? Or, yeah. Do you need to study the lecture notes and the book? So the book, no, you don't need to read the book. There's going to be no questions or anything that come out of the book per se. Most everything is going to be out of the lecture notes. Similar to the homeworks that you've been doing, you'll find some similar problems there. So be familiar with the homeworks and how to do the homeworks. If you have any questions on those, let me know. But yeah, it shouldn't be anything new that everything is stuff we discuss in class, mainly out of the notes. I create the exam out of the notes. How about project work? Are we doing okay with projects? Normally it's around this time where I ask that question because we're coming up on the halfway mark, and you don't have to tell me. I can tell by your expressions that many of you haven't started doing a lot of work on the project yet. So just keep in mind, don't wait till too late, because it catches up with you at the end of the semester. You're going to get a project. Your project will get graded. It's 25% of the grade, and also it's going to be one homework grade, because for the in-class students, what we're going to do in the last class is we're going to spend probably a majority of the class getting a short presentation from you on your project. You'll come up here and you'll do a short presentation, and it counts as a homework. So try to get some progress on that if you haven't started already. Okay. Okay. Yeah. Explain homework 5. Okay, let's. So homework 5 is this use case homework. And so first of all, let me go down to what I'm asking you to do. Let's go to the bottom first. So first of all, let's make sure we understand the deliverables. So a use case diagram is, remember what a use case diagram was, right? So it was the 4 parts. You know, there's the system boundary, the actors, the use cases, and the relationships. Okay, so that's deliverable number 1. Then you'll take one of those use case diagrams and you'll develop a scenario. You know, that's the detailed, that's a short story is what I call it. Remember that? The actors, preconditions, postconditions, typical course of events, alternative flows. No. Okay. Use everything on that template, the one that was like the template that was in the notes. Yeah. Let me. I'll tell you what I'm. Well, I'll tell you what I'm looking for on the scenario. Okay. Yeah. If you go back to the notes, I don't know if, where was this. Like this template. Yeah. Okay. That's a good question. You don't. Let me tell you what I'm looking for in this. I want you to use a template. What I'm looking for in here is okay. This front part really give me the use case you're going to be creating the scenario for. Some of these things, okay, like level. We didn't talk about level. Okay. There's different levels of use cases that you can create. There's what are called business use cases, which are very high level business goals, right? So think of you know the goals of SMU as a higher education you know corporation. What are they fundamentally trying to get done? They're trying to you know they're trying to make profit on selling distance courses. They're trying to, you know, produce research grants at very, very high level. And then there's system level and then component level. So you have SMU, big business. What are they trying to get done? Then you might have as the system level. It might be, okay, as part of the SMU university, we're developing a online course registration system. And what's that? What are the use cases for that? Well, it's registering for classes, adding, dropping. Okay, so product level. And then you can go all the way down to component level where, well, this software component has these different, you know. Now, we didn't talk about those levels. You know, we talked primarily about system level or product level. So like, you know, you take your project selection or we talked about, in class, we talked about ATM machine, you know, that's a product level. So the level, you don't have to worry about that. I'm just telling you that there are different levels you can operate at, but you can skip this one or just put system level, that's fine, okay? This other stuff, last update, you don't need. Status, you don't really need. And they're good if you're doing this in the real world, but because you always want to version control this stuff, but we don't have to do that. Primary and secondary actors are important. Now, if you just put actors here, because that's the way we talked about it in class, that's fine too. There's, in some cases, it's good to identify the key actors and then the secondary. Sometimes they actually call these, believe it or not, supporting actors, just like the movie. But if you just combined all this into actors, that's fine. Preconditions is important. Got to have that. Don't worry about dynamic preconditions. You don't have, if you have any assumptions, document them. The post conditions, I'll get back to trigger in a minute. Post condition is required. Don't worry about failed post condition. We didn't talk about that. And actually, you don't have to worry about the rest of it. The trigger is usually, you know, if it's something that, it says here, it's something that starts a use case. Now, when we talked about this in class, we said that usually a use case scenario is always initiated by an actor, right? And so that can be the trigger. It's the actor doing something. In some cases, the actor could be time. Okay, so like let's say, let me draw it for you. Let's say you're doing you've got a, let's say you have a use case scenario where you want to run, I'm just going to draw some, you want to run some kind of cron job that starts at midnight, okay? You could actually have an actor that represents time passage, and at 12 o'clock you can trigger a use case to initiate or a scenario. Time can be a trigger, okay, and an actor, okay, as shown here. So you can actually use time to start use case scenarios. So that's kind of it. Now the only other thing that we talked about in class that would be interesting or not, it would be useful to include in here is at the bottom, we talked about alternative flows, right? And exceptions. Remember that? So, so your question is a valid one because this template. See, in class I didn't use this template. I drew it, and so what I just iterated to you, what I wanted to see was what I drew in class, but I don't have that note with me. But the template in the notes, which is this one, is actually what we did not actually discuss this. I modified this a little bit during the lecture. So if you do, so again, the key things I'm looking for that you have to have, because I'm going to definitely check it. What are the actors? The actors, the preconditions, the postconditions, of course, the story, and then alternative flows and exceptions. So that ATM example, exactly what we did, and that example is what I'm looking for. Okay, does that make sense? Given that I put this one in the notes, you can use either one. At this point in time, either one I'd accept, but I'm just letting you know that what I talked about in lecture could also, could be used in addition to the one I put in the notes. So yeah, I'm actually as long as you include those things, like I said, the preconditions, postconditions, and those other, anything else, any other template is fine with me. Yeah, on the exam, if I ask you to do a scenario like this, I'll probably put the template in the exam, so you don't have to worry about drawing it all out, and I'll just tell you to fill it out. Okay. Now, yeah, and then you remember what a storyboard was? The storyboard was essentially the scenario, but we added in that little hand sketch of the interface, and so to understand the difference there as well. Remember that? That was like an extension to the use case scenario. But what else? Again, I'll come back. We'll do a summary at the end of class, given that we're not going to have class next week, and we'll walk through the notes, and I'll answer more of your questions. If you have any other questions between now and then, just hold them, and we'll get to that when we get to the end. Okay, so let's see. So where are we going now? We're over here right now. We just the last live lecture we finished elicitation techniques, and then I had you watch that state machine lecture, which is actually part of this modeling section. It didn't, so I had to skip ahead because I didn't have a lecture that was following this SWEBOC format. So I'm going to go back and start at the beginning of this requirements analysis section, and then we're going to start. So I'm going to talk a little bit about classification and prioritization. Then we're going to get into the modeling part, and we won't finish it tonight, but we'll introduce at least a couple additional techniques besides the state machine, and we'll see how far we can get. Okay. So one difficult part of once, hopefully, let me skip back. This was the last slide from when I was here, and we talked about these different data gathering techniques, and these techniques allow you to gather a lot of raw data And once you're through getting this information, these top-level requirements, and even as we do some of the modeling techniques that are coming up, we're going to be gathering requirements. At some point, we have to prioritize them, okay? And if it sounds easy, but when you get a customer and ask them to prioritize the requirements he's given you, let's say he's given you 100 requirements and you're asking him to prioritize, and he's going to usually find that very difficult to do. Customers don't like to prioritize because what ends up happening is that they believe, in many cases this is true, requirements that are prioritized as low, if they force a distribution and have to put some at the bottom, there's many reasons why they'll probably never get done. And so it's almost like a death wish. If you say low priority, that means we're not going to get to them. That's not always true, but some techniques like Agile, which I'll talk about, there's interesting ways of managing that queue. But there has to be some prioritization because it can't just be a random set of requirements. There has to be some that are more important to getting the product out the door than others, and trying to go through a process like this always helps, okay? So why prioritize? Any product, most products that I've seen, there's going to be some absolutely have to have for the product to work and others that are less essential. Also, if you're doing sequence construction, more of, let's say, a waterfall, you want to make sure you're going to get the biggest bang for the buck, the most capability for the least amount of cost. There's always constraints. We talked about this earlier, remember? There's always going to be constraints. Here's just a few of these. And because of that, some of these are going to have to be spread out throughout the process. If you're doing incremental, for example, some will have to come in a later release. Mainly the constraints usually dictate that. By setting these early, it gives you more options for how to manage your different increments. And because some requirements can be very, very expensive, the customer can help you with this. So for example, if a requirement in the list is 10 or 20x more expensive to implement, and the customer understands that, I'll show you how to go through a disciplined approach for doing this. They may help. They may decide that, it's not worth that money, put it at the bottom. So we have to have an ROI applied to each of these as well. Now, prioritization scales vary by organization. There's all kinds of different scales: high, medium, low, essential, conditional, optional. These are two examples that I've seen. We kind of follow in my company. We kind of follow this one. As a matter of fact, we have usually just call them P1, P2, P3, priority 1, priority 2, priority 3, P1 being the highest, which is kind of like the high, P2 here and P3. But whatever scale you use, just be consistent. And some requirements also, we have to weigh them against importance versus urgency. So for example, if a requirement is really important and it's also urgent, meaning the customer needs to see this earlier rather than later in their product, that's probably what will, that's an indicator that should probably be a higher priority category. If it's important but not urgent, think about maybe a medium priority. This one I actually accidentally messed these up. If it's not important and not urgent, if it's not important and urgent, so urgent but not that important, make it a low priority. I mix these up, just switch these around. And if it's not important and not urgent, that's probably what you don't want to bother doing. So I just did a block copy thing here. So switch these two around and it'll work. Now, it may be hard to also determine importance and urgency, but if you do have that information, that's a rough kind of rule-based matrix for how to bin them out as far as high, medium, and low, or don't worry about them. Okay, now let me skip to a table. I'll go to this page. This approach is a little bit more formal, but it might help you if you are forced to kind of come up with a priority list and you might have your customer helping you. I thought that this spreadsheet with these calculations was available on process impact, but when I went out there, this used to be free. Now if you go out to this website, they're going to ask you to pay money for it. So I think it's only $5, but you can do this in a simple spreadsheet. I wouldn't buy it unless you really want to, but you can create this with a spreadsheet. Here's how this works. We have a set of features. These can be your requirements. Okay. We have a set of factors that we're going to apply to each requirement, including the relative benefit this brings to a customer, the cost of doing it, the total value, the penalty, meaning the amount of relative effort to do it, the total cost, the risk to do it, because some of these are low risk and some are very high risk, and then ultimately we're going to calculate a priority 1 to n. And let me explain to you how this works, because it's actually quite interesting, and I think it takes some of the emotion out of the discussion. So let me talk about this. So again, I'm not going to go through the features. They can be any set of features. This is for a chemical process control plant. But anyway, they're not that important. So you want to list all features. You can also do this by use cases or detailed requirements. Sometimes a requirement, you can have multiple requirements for a feature. Any way you want to list them is fine. Okay. Then the customer representative has to assign the relative benefit for each of those, from not useful to valuable. So that's what this first column is. Okay. So what you can do is you can ask the customer, hey, listen, you go into these features, requirements, use cases, whatever, and you assign a weighting. Now, it doesn't have to be 1 to n. You can see in here there's a couple like this one and this one, very high priority. So you can assign the same relative benefit, but you would like to spread them out a little bit, okay? But they assign that. I'll let the customer assign that. There's a row up here called relative weights. You can actually weigh each of these factors that we're going to be applying if it's more important than others. So these relative weights are examples of what I put in there. So this relative weight is a factor of 2. So we're going to essentially take these and actually weigh them more than others. So you can actually weigh each of these things that I'm going to talk about. That's what the relative weights is. Okay, so customer representative. Remember what a customer representative is. It could be a marketing guy, a product manager. It could be the customer. Okay, now what is the penalty if the feature is not included, which is this. I have a weighting of 1, uniform weighting. By the way, for consistency, if there's nothing here, that's a relative weighting of 1, 2. I should have put 1s for all those. So if it's not done, what happens? No one will be upset, weigh it low, serious downside, lose business, competitive pressures, what have you, weigh it high. So you can put a penalty in this column, okay, if we don't do it. So again, what is the penalty if we don't do it? My company goes bankrupt, well, that would be a 9. Or a couple customers will complain, but not, we won't, they're small customers, so we don't care too much. That's more like a 2, okay? So that's that column. Then calculate the total value. So it's a benefit plus the penalty, and of course you can apply the weight. So this particular one, for example, this row would be 2 times 2, so 4 plus 4, because this is a multiplied times 1. So it gives you a value of 8. And you do the same thing for each one of these. 5 times 2 is 10, plus 3 is 13, et cetera, et cetera, et cetera. So you end up with a value here of 155, which is just the sum of everything in that column. Over here, this is, by the way, this is a sum of everything in this column, the relative penalty right here. I put the sums down there. Okay, Now, the total value, value percentage. The value percentage, this column is a simple calculation. It's just the total value, 8, divided by the sum, 155. So you get this value percentage of 5.2%, okay? Following me so far? Okay. Let's go back. So we've done that. Developers, by the way, we do that. We do that just to get a spread. We're trying to get a spread here, and we're going to use that later on. Now, we have to also look at costs. When you're implementing a requirement or feature or use case, you do have to look at the effort to do it. And this is something that, requirements are not made equal. Every requirement doesn't take, 2 man-months to go off and implement. Some of these are really easy, quick and easy, so we'll assess those lower. And some are really hard, time-consuming, expensive. Now, you don't have to know the exact amount of time. This is just a scale. It's helping us by providing a relative scale. So in the cost, I'm going to put down which ones are easy to do and which ones are really hard to do. Now, in my experience, you can fairly quickly, by talking to some experienced engineer, determine whether something is going to be easy or hard. I mean, it's, now exactly how much, yeah, we have to do more work in that area, but you can get a relative cost pretty easily. Okay, that's what this is. Okay. Now, again, if you add all this up, this column, the values in here are obviously somewhat subjective, but you go through that process, talking to your trusted allies. So you put a cost, you add that cost up 37. Then for each of these, you just divide whatever's in that column, like 1 divided by 37, 2.7%, 2 divided by 37, 5.4%, et cetera. So now you have a relative cost percentage in this column, okay? Just total contribution in this column divided by the total. So you get a cost percentage. And then finally, you always have to look at risk. Degree of technical or other risks. Remember when we talked about the spiral model earlier? What was the spiral model built upon? It's risk assessment, right? You try to assess the risks early. And so if the early risks you're trying to assess in that spiral model, those would be probably higher ranked in that list of functions, right? That's why you're doing spiral with it, right? If it's really easy, no risk at all, done this many times before, piece of cake, you can weigh those lower. So in the risk, and I've got this weighed by half just for example purposes, but again, if risk was really important to you, like you absolutely had to be able to deliver on time, and you're taking high risk in some of your requirements, this might be 1 or even 2, but you put your relative risk weighting in there. So here's the risk calculation, and again, a risk percentage. So you divide the cell by the total, and you can get a risk percentage. Again, what we're trying to ultimately look at is percentages of risk, cost, and value, okay, for each of these requirements, based on our scale, our 1 to 9 scale that we have somewhat subjectively filled in here for each of these requirements. Now we're ready to roll up the total priority. And the calculation, I've got one example here. So we're going to take the value percentage of each requirement, and we're going to divide that by the cost to do that requirement times the factor on cost, which here is 1. Okay, I should have put 1 here because that's the default. Plus the risk percentage, 3 times the weight, 0.5. Okay, and you end up with a scalar number. All right. Now I've got the example in there, and there's a formula, right? There's a formula right there, okay? Value percentage, the value it's going to bring divided by the cost to do it plus the risk, okay? Every requirement, the value it brings has to be offset by the cost to implement it. You know, there's a cost that could be, it's an opportunity cost essentially, and then of course the risk. So you end up, now once you end up calculating that, okay, you just order rank all the requirements, which I've already done. You can see the highest one is your top priority, and it goes all the way down, okay? I already pre-ranked them so you can see it. That's this column here. So more, you know, a little bit more math, but it gives you, I believe it gives you a good, it forces you to think about the key factors, which is, you know, risk, cost, and value to the organization or to the customer. And it takes a little bit of emotion out of the discussion. Okay? So that's a prioritization approach that is used often. Again, you can see how it's very easily implemented with an Excel spreadsheet. If you know, don't worry about spending $5, create your own. And then what you do, I mean, you know, is you literally sit down and have a few sessions with your customer and with your developers. Your customer does the value. Your engineers provide the cost, and the manager provides the risk. Okay? So that's how a prioritization matrix works. Again, at the top is your algorithm. Questions on that? Okay. You can also look at feature sets. If you've got a different feature set for, say, maybe you're doing an iterative or incremental development. You've got multiple releases or versions of the software. For each of these, you can look at, you know, you can plan and spread out the features into different versions. So, you know, each version or iteration, you can also do that if you're doing Agile. There'll be some, you know, different level of priority in your feature sets, again from the previous discussion, some of which, you know, you can prioritize into the versions, some of which you can backlog. I'll show you an Agile queue in just a moment. And you can make some decisions as to what, you know, what priorities are going to go in which version. So once you go through the kind of this process here, and you've got all these order ranked, what you can do is you can begin to plot those into different versions, okay? Based on the relative priorities that we calculated here, okay? So map those, maybe like with an Agile approach, you draw the line, you know, after each 2 or 3 different requirements, or with Agile, if you're doing Agile, maybe these could be user stories. That would also work. And then you can map those into iterations. So just because Agile says we are going to do monthly sprints, iterations, and we'll stop whenever customer doesn't have any more requirements to implement. Again, in the real world, you don't want to tell a manager that you don't know when you're going to stop iterating. So you can do some iteration planning ahead of time, and that would give your customer and management an idea of what's going into each one of these iterations. More on iteration planning when we get into some Agile stuff. Okay, so just that section on prioritization, I wanted to introduce it because it's important that you understand that all requirements are not created equal. The key things you need to kind of take away, there's each requirement has a value to the organization, but it comes with a cost and a risk. And all those have to be kind of weighed against each other. And so just be cognizant of that. It's a good way of forcing a distribution of your requirements. Okay, so okay, now in the SWEBOC, let me go back to the beginning. So I just talked about that session. We're going to get into some modeling, and we'll stay there for the rest of tonight. And when we'll stop there, whenever we stop tonight is what will be on the midterm. We'll talk about that a little bit later. Okay, so modeling techniques. Now, you already did some modeling techniques. A use case is considered a modeling approach. The state machine discussion, the activity diagram, sequence diagrams, they're modeling approaches. But if you back up a second, I'm not sure if any of you guys have seen this picture. If you've done any system engineering, you probably have. This is called the 4+1 model view, and what it is, if you're going to be an architect of any sort, an architecture document might require different views of the application you're building. And this is an attempt to show that. So for example, and they call it 4+1 because it's the 4 views plus the scenarios, think use case scenarios, that have to also be considered for context. So we know we've already talked about this, right, already. And what we're going to do is we're going to talk about some of the different views and how to express that in a modeling or a software requirement specification. Now, very quickly, if you look at this picture, the logical view is mainly about functionality. Use case diagrams, sequence diagrams fit into that category. So again, primarily functionality, not necessarily performance. The process view down here are the dynamic aspects of the system. In the lecture from last week that's posted online, we talked about activity diagrams. Remember that? So that would fall into it. That's an example of a process view or a dynamic view, an activity diagram. Oops, I thought I had my other ones. The development view and the physical view are things we're going to talk about. The development view, we're going to talk about data modeling and flow, and the state machine also fell into that. And then the physical view would include, we didn't talk about it yet, but it could include things like deployment diagrams. So the physical view would show how your different components are physically distributed in the system, okay? What servers they're running on, things like that. So in UML parlance, one of the interesting modeling approaches is called the deployment diagram. We haven't talked about it yet. We may talk about it a little bit later. But it's all around this kind of different views of modeling. That's the key message here. And because of that, what I want to talk about now are different modeling approaches. And so what we're going to do now, we'll get into this, and let me just add a little bit more commentary on this. So models are really important in requirements engineering because a lot of these allow you to get more clarity on the what, and sometimes you find some pretty good hidden requirements when you go through some of these modeling approaches. And there has to be different views on the system. Almost always there's more than one. There should be more than one view. Now what we talked about, there's different types of systems where different views make sense. So for example, systems that are event-based need certain modeling approaches. The one we talked about last week was a state machine, or the one, the videotape. Event-based, what's an example of an event-based system? Okay, well, if you're anything with a user interface is essentially an event-based system. There's events through the interface that can be modeled. And if you remember the lecture last week, remember I showed that example of that little recording machine where it was the what? Well, the Coke machine, but then I think I also showed the little DVD player with the event-based thing. So that was an interface. So the user interface is an event-based. Any real-time system is probably an event-based system. Okay. Now, there's also now these systems, like real-time system, example of that would be, typical example of that is a monitoring and control. Monitoring and controlling the environment. Like for example, an alarm system where if you trip, an alarm, if you trip, alarm, big siren goes off, an event, that's an event. So monitoring and control. Now these systems have very little data in them. Like they don't have a large, if you look at your security system at home, it's an event-based system. You open a window, event, triggers the alarm. But you don't see those systems having large databases, do you? There's no need to, right? So the right view there is an event-based view. Now we also have data systems. Some systems have a lot of data structure. For example, IT systems, where you have a large, relational database storing maybe millions of records of employees and, retirement accounts or medical records. When you have large large data from an IT perspective, structures of data, we have to understand what the right structure is and how it manifests itself in the interface. And then we also have systems where we're not storing a lot of data in the system, but data is flowing and getting transformed as it goes through the system. That's a different view yet. And then there's other systems where one of the most important things is concurrency, where you have many things potentially happening at the same time, and you have to show concurrency. You have to show, synchronization, right? This is an important class of system, and we have to show that as well. Okay. Now, so in this next section, we've already talked about this one, but we have a few other modeling techniques we have to talk about, again, some of these are more applicable to certain classes of systems than others, and so keep that in mind as we start to go through, this next section. Again, we already talked about the state machine last week. Okay. Some of these you might be familiar with, but I'm still going to go through an example with you anyway. Okay. So I want to start with data flow diagrams. Okay, and I'll walk you through this. So how many people have heard of data flow diagrams? Couple, few. Okay. Here, this form of model can be very useful for classes of systems where you have information flowing through the system, and you need to understand how that information gets transformed as it flows through the system. So the example I want to use for each of these modeling approaches, I'm going to use a different example. So we used the Coke machine for the state machine, right? This time we're going to use a different example. We're going to use a travel reimbursement system. So when you travel, on your job, and when you get back from your trip, so I got back from Europe, I have to submit a travel reimbursement form. Okay, so the company can reimburse me for expenses during my trip, right? And so this system is going to automate that process for me. Okay, and so here's how a data flow diagram works. It's actually pretty simple, but I'll draw it for you anyway. As in a lot of these modeling techniques, the first thing you want to do is draw your boundary, system boundary. It is always important to know the boundary because you have to know, in this case for data flow, you have to know what data is flowing into your system and which data is flowing out. So we're going to call this the travel reimbursement system. Now data, like I said, data comes in and data goes out. Data comes into the system from the external environment outside the system, and they usually come from specific sources of that information. Okay, So for example, when I want to submit expenses into this online travel reimbursement system, me as an employee will have to submit something. Usually it's an expense statement into the system. And an expense statement is information. And the way you would represent that is with an entity. So out here we have entities, and there's a couple different ways you can draw them. Let me draw it this way because it'll make a little bit more sense. I'll draw it like my typical little actor guy, and I'll call this employee. Now in a data flow diagram, these things are referred to again as entities. Okay, and what I'm going to submit into this electronic system, think of me doing this through a browser, at my desk. Okay, is I'm going to submit information into this system. Okay, now what information am I going to submit? There's different ways you can label that information, but I'm just going to say that this is going to be, I'm going to call this submitted travel form. Okay. Now this arc, okay, unlike last week where the arc in a state machine indicated something. Do you remember what it indicated last week? Last week when we were doing a state machine, and we had a state, and transitioning to another state. What was that? What did that represent? An event, yeah. It was an event with a possible response, right? So that represented an event, and these were states, right? Now, on this one, it looks the same, but it means something completely different. The arc in this, in a data flow diagram, it represents data. It's data, information that's flowing. It's not an event. So if you put something on this arc that reflected an event, like threshold crossed, or yes or no, that's wrong. This is information. So this information is submitted travel form. Think of an electronic travel form with all my expenses and okay. Now this information is going to go into the system, and I have to do something to this information. Okay? Let's say the first thing I'm going to do this information is I'm going to check for correctness. Okay? And I do that in this little bubble. Now this bubble is referred to as a data transformation. Okay? It's going to transform this data that's flowing into it. So I've got this information, submitted travel form. By the way, the fact that this is data, it should be a noun. Okay? This should be a noun. And then it's going to flow into this transformation that's doing something to it. Check for correctness. This should be a verb, action, verb. Okay? So that's the first step. Information flowing in, check for correctness. Now, out of this transformation, check for correctness, there's two potential pieces of data that can flow in the system. I could send that information onwards, and I'm going to, since I check this for correctness, okay, the data flowing out has been modified, right, in some form. I'm going to call the data flowing out of this transformation. So I had submitted coming in. I'm going to call this approved travel reimbursement. Yeah. So I've checked it for correctness. Okay, all the fields are filled in. You didn't leave out any required fields, blah, blah, blah. Okay, it's approved. Move on to the next step. Or I could send information back to this entity. I can call this a disapproved form plus errors. In other words, I'll tell him what he did wrong, right? Hey, you forgot to fill out, this field, and this was incorrect, and so I can send. So I can either send it on or return it, right? It can be either one, but it's not important. These are just the different flows. By the way, as another thing, if an entity is sending information into the system, we call that sourcing information. If the entity is receiving information from the system, we call that entity a sink. So source, sink, okay? All right, now, it's been checked for correctness. What do I want to do now? Let's say I want to convert currency to US dollars, okay? So I submit in euros or shekels if you're in Israel, and because all my receipts have are in those currencies, local currencies, and I have to convert it to US, okay? So I do that, and now in order to do that, what do I need? I need some information about the currency conversions, right? So I'm going to assume that I'm going to access a local database, which I'm going to call a data store. I'm going to represent it like this, and this is going to be called, I'm running out of room, so I'm going to call this currency conversion data, okay? So basically it has all the currency conversion stuff. Think of, if you go online, you can find these currency converters, it's a little data store of all the different currency conversions for the different, okay, and I'm going to pull in currency conversion information into this, okay? Again, I want to label every arc. So with the approved travel request form and the currency conversion data, I'm going to produce, because then again I'm doing a convert currency to US dollars, I'm going to call this let's call this a converted travel request form. Now notice again we have data going in, it comes out modified, different name, goes in, comes out modified, different name. That's what you expect when you're developing one of these, is that you don't expect this name to stay the same. Otherwise, what are these transformations doing to it? The fact that this is a transformation, by definition, means that it should be doing something to this information, transforming it in some way. Okay, so I do that. Now, now I'm going to I have one final step. I have to management approval. So it's been checked for correctness, it's been converted, now it's got to get approved by management. Okay? So when management can either do one of two things. Management can either disapprove it and send back disapproved travel request form plus reasons. Again, it's information, it's data. Yeah. Yep, sorry about that. So management approval, I'm going to send back either a disapproved travel request form plus the reasons back to the employee submitter, or submittal. Okay, I can do that. Or I could approve it. So let's have another data flow. Let's do this just to make it interesting. I've got another entity out here that's going to be the finance person, okay? And if it gets approved, I'm going to send the manager approved travel reimbursement form to finance. Let's just say I'm going to send finance a report and she'll issue the check, right? Okay? So again, I'm syncing that back out to this finance entity. And what I also want to do is everything that's approved, I want to save that in a data store. So I'm going to also call this the manager approved forms. And I'm going to store it in this travel approval database. Sorry, I'm using all these acronyms, but I'm running out of room. So some database that's going to hold all the approved forms, okay? So far, so good? So let's summarize what are the key parts of this data flow diagram. We have a boundary. We have data flows coming in, going out, moving through the system, okay? We have entities that could either supply or source data or receive or sync data from this, system. So entities, data flows. We have a data transformation that modifies the data as it flows through the system. It transforms it, does stuff. And then we have data stores that hold information in the database. Okay. So those are the key components of a data flow diagram. So far, any questions? Okay, now let's assume someone comes along and says, "Well, Rob, that's great, but this travel approval database, information is going in, but how do you ever get information out of it?" This is actually a potential issue. Anytime you see something where stuff's going into a data store, but no one's ever getting anything out of it, you got to ask yourself a question: what's happening to all that data? So let's say that's used because a manager, so let's draw another entity, a manager wants to be able to view all those forms periodically, okay? Now, it's illegal for me to draw a line, remember these are data flows, directly from a data store to an external entity. Think about it. Some external entity can't directly grab information out of a data store. So instead what we'll do is the following. We'll add this little thing out here, another data transformation. And what we're going to do is we're going to pull that information out of the database, the approved travel forms. Remember to label each arc. I'm running out of room, but this could be travel forms, approved travel forms. Let's say I'm going to format, report, and then I'm going to send a report to management, okay? So don't have an entity pulled directly from a data store. Likewise, let's assume that these currency conversions change a lot, right? They don't stay the same, right? So some system is normally updating currency conversion. Literally, if you go out to some of these currency conversion applications on the web, and if you look at it, every time you refresh, or sometimes it'll do it live, they're updating the conversions almost every couple seconds, right? So let's say your system, you wanted to do that too. And so you can show that by saying this can be some kind of, I'm going to call this entity, there's certain forms of banks that maintain all the conversion information, like US dollars to whatever. I'm going to call this bank just for the moment. And the bank, and again, I apologize for running out of room here, but the bank could update this data store periodically with the new conversion information, right? Right? But I can't update it directly, just like down here, I couldn't pull information directly from the data store. So instead, I'm going to have to go through another process transformation, and I can do that. I can have one here that just does I can just do a simple update, okay? So I'll send in updated currency conversion data, and that will update the data store. So this new data transformation that says update, I couldn't fit it in there, will take information from this external entity bank, updated currency conversion data, either update the data store or format it and update the data store. So now I show that this is being updated and then pulled every time I want to do a conversion. Okay? So that's kind of it. That's a data flow diagram. Again, question?
Is there different levels of data flow diagram?
Yes. Are there different levels of data flow diagrams? Definitely. Each of these bubbles, as a matter of fact, at the top level, okay, the answer is yes. Each of these can go, you can break this up into multiple levels. You can even have a top level view that looks like this. I can have, what did I call this? Travel reimbursement system, like that. And then I can show this talking to all the various things around it, like these entities. I got 4 of them here, so I can show this. Okay, and then I can show information flowing into the system, in and out of the system. And so, for example, the employee, remember it was a source and a sink, and what is it, stuff going in, stuff going out, right? So you would just label these the same way, submitted, travel form. You take these same names that are across this boundary for employee and show them on this. Bank, updated, this would be updated currency conversion data. The manager gets reports. The finance person gets, I didn't label this, manager approved travel request forms. So this would be manager. So this is the top level, right? So 2, 3, 4, stuff coming in, stuff going out. And I can label all that. Okay, this sometimes is referred to as a context diagram, or it could be, sometimes it's referred to as a level 0 data flow diagram. Okay, level 0, this would be 0.0, and then if you wanted to break this down to the next level of detail, you can come down here and again preserve the interfaces. The interfaces stay the same, and this could be something like 0.1, 0.2, 0.3, etc. And then you can go into more details if you want. You can go down multiple levels of detail. Yeah.
What about the external databases?
Yeah, if it's an external database, that's where this little stick man gets a little bit misleading. The entities that are external can be a person, a system.
But we go within the level 0, right?
Yeah. And anything external, you can draw. Like if there's a database or something, another system. Yeah, if this is a financial system, it doesn't have to be a person. Maybe this is a financial system. It's an entity. Okay. Now the other thing when you're with these data flows, we have. I was putting some fairly vague names on these data flows, like submitted travel form. We can go more detail on this too. We could have, we can create data expressions. I think I've got an example coming up where this, what did I call it? Submitted travel form. So submitted travel form actually could be made up of multiple things. It could be made up of like name, employee number, place visited, date. So you can break this up into more levels, more details. It's, sometimes this is referred to, but don't worry about it. We're going to talk about this a little bit later. But sometimes these things are referred to as data expressions. Okay, and data expressions get stored in places called data dictionaries. Okay, don't worry about this right now. You're not going to remember this because we haven't gotten to it yet. I don't think it might be coming up here shortly, but the point I'm trying to make is these vague descriptions, high-level descriptions, actually this would follow first. These high-level names on these arcs, it is possible you can break those down into a lot more details if you wanted to. You know, so because of that, these things obviously scale in abstraction, so you can generalize these or make them more detailed depending on what you're trying to get done, okay, what you're trying to show. Okay, other questions on this? Yeah.
What's the difference between actors and entities?
Well, the different modeling approaches call them different things, you know. So in data flow diagrams, traditionally, they're called entities, but if you want to make a relation between an entity and this and an actor in a use case diagram, they're almost exactly the same. It's you know, and yeah, like for example, both of these can be an entity and an actor can both be a person or a thing. Now they're, you know, what they're used for is slightly different. And entities here are sources or sinks of data. In a use case, it's more of an interaction detail, not so much data going across necessarily. So, yeah, it may have been misleading when I drew the stick man again over here, but they're entities, and they are a little bit different than what you'd find in a use case. Other questions? Well, if you go back to let's go back to the notes. I do have a few more details just to fill in this discussion. So if you're building one of these, by the way, your next homework I'm going to post will have one of these. We're going to practice this. It'll be good if you do it in the next week. I can post and submit it. I can post a sample solution. You can use it for the exam. So this is the summary. So now you see again sources and sinks. Those were entities. Data conversion, temporary storage. I call that a data store. And the arcs are the data flows. Now again, arcs, of course, should be labeled. I will take at least 1 point off every time I see an arc that's not labeled, because I really want to enforce. Same with the state machine, where the arc will have an event on it. Don't leave these unlabeled, because it's important to show how data is being transformed as it flows through the system. This goes into a little bit more detail. I'll let you read it, but I've already talked about it. You know, like I said, entities, okay, people, organization, other systems. We already talked about that. That forms the boundaries because of, like I just showed you, they're outside the system by definition. Yeah, one thing about the arcs, it's data in motion, unidirectional. You can't have an arrow on both sides. We specifically are trying to show data flowing, and we want to show it flowing in, you know, one direction. If the same kind of data is flowing back for whatever reason, show a different arc flowing back, but make them unidirectional. That's important. Name them specifically, but keep in mind you can also these abstract. And do not show control flow. I get this mistake a lot too. Like I might, every now and then I'll get things like this. I'll get, you know, remember these are data flows, and I'll get something like this. Okay, that's not, those aren't data flows. That's control, right? So that's wrong. So don't do something like that. So show data flows. Again, it has to be a noun. You know, it's a good indicator that there's, you know, data there. Talked about this. Okay, that's just for you to read. Nothing else I think I want to say. I mentioned how verb-based for the process transformations, nouns for the stores because it's storing something. Here's my little travel. Now, what I just drew for you live in class is a little bit different than what I drew in the notes. Either way, don't worry about it. You got the picture now. You know, we went through it step by step. But that's just the picture that we just drew in class. there's a few other let me tell you about a few other just general do's and don'ts for these data flows. Okay, I'll do it with red, just so some other things you should not do. Okay, don't do this. Don't show communication externally between entities like that. Doesn't matter. Who cares if these guys talk or not? It's only applicable in here, right? Don't. I told you can't do this. Don't send information directly from a data store to an entity. Don't send information directly from an entity into a data store. You can't do that. You have to go through put a new transformation in there and have them get involved, okay? Don't do this. If you have a system, and if you ever find yourself in a situation like this where you have a data transformation, I'm not going to label it. You have a data transformation, and your system, maybe it looks something like this. That's an issue. Why does something just start and emanate out information? Sometimes this is referred to kind of as like the God type of structure where things just start sending stuff. That's okay. This is also information just goes in there and stops. This sometimes is referred to as the black hole. Things just go in and nothing comes out, right? Black hole. You don't want to do that, okay? Don't do this. Let's say I've got a system and I've got some data, okay. Don't do this. Two databases can't exchange information directly between each other. If you want to move information between one data source for whatever reason, again, put a process transformation in the middle, okay? Let them do it. So you can't do things like that. I think if you follow those general rules, you'll be okay, and label everything and keep your nouns and verbs separated, no control flow, I think you'll be fine. Okay? So again, data flow diagram. So what we did, again, just to summarize, last week when we talked about state machines, we had this diagram that looked like this, and we had the circles were states, and the arc was an event with a potential response. Now we introduced this new concept that looks the same, okay, but now this is data, and these are transformations on that data, okay. So diagrammatically, they kind of look the same, but don't get confused by them. Make sure the state machine, you've got it, you're addressing the right things on the arcs and the bubbles, if you will, okay. Makes,
Same process can share the data to different process.
yeah. You can share between different data to different process transformations. Is that what you're asking? Like the process transformation can send data to different places. It can even send the same data to different places if you want it to. Like I can have approved travel request form going somewhere else too if I wanted to.
And final flow would be like close to the entity or something.
Well, normally in systems like this, you will see, again, you'll have both sources and sinks. So you'll have something that's sourcing or supplying information into the system, and eventually something's probably coming out of the system, some information. So there'll probably be at least one sink in many systems. I think you probably have at least one, you know. Okay, so again, data flow, when that's important. Now, all right, now this next step, this next approach, see these things right here that I call data stores? Okay, now, there's a couple interesting things I want to mention about these data stores. In this example, notice how both of them have an external entity involved. Like, for example, this one, this travel approved database, we said that a manager is going to want to look at the approved travel requests, right? So the manager has to be able to visualize information out of that store. And we said over here, some external entity has to supply information into this data store, okay? So there's this interaction with these external entities. Now, if I want to look more at what is the structure of the data that needs to go into these data stores, now I want to view this system a little bit differently. So this is, again, a data flow view, but now we have to consider for systems that have a lot of, let's go back to this. So now if we have systems that have a lot of large storage requirements, like many IT systems, now what we might be interested in is looking at how this data is structured. Okay? So now I want to look at this type of approach. Over here, these data stores, this right here, this database, right? That database, that is these data stores, right? But now I want to say, okay, I want to look deeper as to the structure of that data store, and this next modeling approach does that, okay? So now I want to talk about this next approach. Has anybody in here designed a database? Anybody? If you designed databases in the past, you probably used this modeling approach. It's referred to as entity relationship diagram, right? Are you guys familiar with this? Okay. Now, a lot of database guys do this to help them normalize their databases, and that's good. But I'm going to take a different approach in here. I want to use the same approach for eliciting requirements, finding hidden requirements, and also finding some user interface requirements. Okay. Now, when you look at data like this in a database, okay, think about data, the life cycle of data in some form of a database. Okay, so hold that thought. So, did anybody take my requirements class before I start? No, okay. So the example I want to use, if you did, this next 30 minutes would be a repeat. The example I want to use is going to be a hotel reservation system. Okay. We've all stayed in hotels, right? So when you walk into a hotel, and you come up to that desk, and behind the desk, someone's standing there to check you in. They've got that computer on their desk behind the thing. That's what we're going to build. Is we're going to look at that hotel reservation system, okay? All right, now, what would be, first of all, let's think of the key, very high level, almost like product level use cases for this hotel reservation system. What would be some of the key functions you would need to perform with this hotel reservation system? I'll start it off. You'll probably want to check someone in, be able to check in a customer, right, or a guest. What's that? Okay, well, yeah, you want to give them a reservation number, but at a higher level functions or tasks, you want to be able to check someone in, which probably means you eventually want to be able to check someone out, right? Okay, how many days? Those are a little bit more details. How many days? That's, think use case. How many days is not a use case? How many days is more of a, what's that? Provide availability. Okay, you get the picture. Ability, maybe provide services, things like that. Okay. So those are some of the tasks. Now, what if this hotel reservation system needs to have a database associated with it, because I'm going to be storing information on this database. Think of a large hotel chain. You know, there's very important data that those hotel reservation systems have to store. You know, what would be some of the really important information? Again, think high level classes of data that this hotel reservation system would have to keep information about. It'll have to definitely keep information about guests, right? Think about, you know, when you check in, rooms, information about rooms in the hotel, maybe information about the services that the hotel provides, et cetera, et cetera, et cetera, depending on the size of the hotel. Okay. So we have some key types of data. We have tasks. Okay, good. With this model, again, this is going to be all about data structure. Okay. So what does that mean? We're going to try to understand the structure of what's going to go into this large database or data store, okay, that we have down here. Now, when you're doing a entity relationship diagram, just like the name says, there's a couple key components to this. The first one is the E in the ERD, which stands for entity. Now, entity, think of entity as a class of data. You know, now we talked about some important classes of data over here, like guests. If you've had any object-oriented computing, you know, think again, what guest would be an important class, right? The way we represent that is just with a simple box, so I can draw something like this. And that just says guest is a entity. It's an important class of information, right? Now, if I was to give you a natural language description of a hotel reservation system, remember what natural language is? If I were to give you, actually write in English or whatever, natural language, I was to describe this hotel reservation system like you would in a requirements document, guests would be a good indicator of which entities you had in the system. Would be, you'd highlight the nouns in that description, and the nouns would probably be a good indicator of the different entities or classes of information you had to hold in this system, okay? Okay, now, as a guest, when I check into a hotel, is there information about me that I have to, that's important to the hotel? Yeah, like what? Like name, phone number, address, etc. Okay? Those are referred to in a ERD, these are referred to as attributes. And if you were, again, if you were to read that same natural language, you know, description, which I'm saying that because that's probably what I'm going to give you, is a natural language, English language description of a problem, and ask you to create one of these models. So you take the nouns, put them in one list, and you're going to say, okay, those are good indicators of possible entities. If you take the adjectives, those are probably a good indicator of what are the attributes. Like, if I talk about people, if I talk about guests and their names and all this other stuff, these attributes are associated with that entity. Usually these are the adjectives you'd find in a description, natural language description. Now the final thing, we know we've got that part. We know we're doing a diagram. This relationship part, okay? R stands for relationship. And what that means is it's a relationship between two or more entities that are tightly related or that need tight coordination between them. Before I get to that, what are some of the other important entities? I already did the guests. I could do rooms if I wanted to, right? Let's just put rooms down here. What would be some of the attributes of the room entity? Room number, single bed, double bed, maybe smoking, non-smoking, right? So the fact that this says room number would imply that what we're talking about here is a specific physical room number, right? In the hotel, like, room 234, a specific room number in the hotel, physical room number. Okay. Now, the next part, this relationship, is trying to establish where we have a tight bond between two or more entities. Now, in the case between a guest and a room, do you think that there would be a relationship that exists between guests and rooms? And I would say there probably is. If a guest stays in a room, for example, right, or checks into a room, etc., when you're looking at relationships, whether there's a relationship between two or more entities, in the natural language description, look for the verbs. And if you highlight the verbs, normally a verb will be essentially a connector between two nouns. Like, for example, guests stay in rooms, or something like that. So we have noun, verb, right? So if you have this verb, think of that as a way of connecting these two entities right here, right? So the way I'm going to show that on this diagram is I'm just going to connect them like this, okay? That means these two guys are related. Now, once we establish that, we have to look for one more thing in this relationship section, and that is something that a term you may have heard of before, and that's cardinality. Let me explain what that is. Cardinality is a relationship between amount of, okay, or numbers that between two, in this case, two different entities. And so what would a card, now there's three different types of cardinality. Let me draw those first, okay, that you need to be interested in. If I have two entities like this, entity 1 and entity 2, like guest and room, I can have something called a one-to-one cardinality, and I just show it like that. If I want, I can do something like that, one-to-one. That would say, this thing would say that there's one guest in one room, okay? One guest, one room. I could have a one-to-many relationship, one to n, all right? This little indicator here, if I were to take, if I had this entity E1 and I want to show a many relationship, so E1 has a relationship between many E2s, and if I were to draw something like that, see that little crow's feet indicator right there? Okay, that's what this is. All I've done is I've just condensing, not having to draw multiple E2s. I'm just going to show it like that, okay? So that says E1 can have multiple E2s. So if I had something like this, and let's say I did something like this, that would say, the way I would read this is a guest can have many rooms, and a room can have one guest. See, when you're trying to convince yourself of the cardinality, you have to talk about it both ways. So you have to go guest to room and room to guest, and you have to read it with the cardinality in mind. So again, guest can have many rooms, a room can have one guest. Okay, now the third cardinality is many to many, okay? So N to M. And I'll come back to that in a minute. Okay, now with this in mind, let's go back up to this example between guests and rooms. We want to establish what the cardinality is between guests and rooms, and we have to somehow figure out what that should be. So the way it's currently stated is it says a guest could stay in many rooms in that hotel, and a room can have only one guest. Okay, now think about it. This is where you want to maybe bring in the domain experts, or kind of talk yourself through it with the engineering team. But the way you do it is you say, okay, well, does that make sense? So a guest. So when I check into a hotel, me as a guest, can I stay in more than one room? Now keep in mind, maybe I check into this hotel many times during the course of a year, or a couple of years. When I check into a hotel, do they always put me in the same physical room? No, right? Remember this room number that you put down here? I drew this over here, room 234, to indicate that this is a physical room in the hotel. So, okay, so they don't always put me in the same room. If they did, that would be kind of weird. But if a hotel had a business rule where every guest can only stay in one physical room, then this would be one-to-one, right? Okay. But when I check into a hotel, I can stay in more than one room, whatever room. So this many makes sense. One time it's room 234. The next time I check in is room 960, whatever, okay? Now, this physical room, room 234, can it only house one guest? No. I mean, if I stay in room 234 one night, the next night somebody else, another guest, is going to stay in room 234, right? So, if that's the case, if a room can have many guests, then I have to go like that, right? Okay. All right. Now, so far so good. We getting the concept here. Now, there's one little problem, and this right here, this many to many, is generally not a good idea. And there's a couple reasons for it. If you're a database design guy, this is not a good idea because it makes it harder to normalize. In other words, there might be duplicate data between these different entities, and that's bad if you're a database designer. But more importantly, from a requirements perspective, when you see something like this, there's normally something in the middle there that you're missing. In other words, there's hidden requirements in there, okay? So here's what you do when you see something like this, many to many. There's a simple little conversion you can make. If you decide that you have a many to many relationship, right? Here's what you do. You have to transform that into the following. We're going to still keep E1 and E2, right? But now what we have to do is we're going to add a new entity, E3. I'm going to break that connection, and I'm going to go like this. Okay? And then what I have to do is decide, you know, what E3 is. Okay? Now, technically, this is referred to as a junction entity, if you're curious. And normally, when you get yourself in this position where you have this and you're trying to figure out what this is, normally this would be, E3 would be, in many cases, referred to as an abstract entity. Now let me give you an example. Again, how many people have some object-oriented development knowledge? A little bit. You know, with object-oriented development, when you're creating your objects, you try to create objects that are very similar to real-world objects, right? Okay, in your system. With an entity relationship diagram, the entities, it can be these kind of real-world things, like guests and rooms are real-world things, right? But they can also be abstract. Let me give you an example of an abstract entity. Let's say you're a store owner, and you want to have, and during the course of the year, you have multiple sales, right? Each sale could have some kind of start and end date. It could have, maybe it's a certain discount rate, or et cetera, et cetera. But that's a noun, that's an entity, that's a class of data, but it's abstract. In other words, it's not something you can reach out and touch, right? Here's another example of an abstract entity. Wedding. Wedding is an event, but if you're a wedding planner and you're creating a system for a wedding planner, then a wedding with, again, a date and a spouse, husband and wife, that could also be an entity, a class of information, right? So a wedding planner would have a database full of weddings. Agree? So these can be entities, but the fact that they're not things you can physically reach out and touch. Sometimes we call these abstract entities. Well, the point I'm trying to make is, whenever you find yourself in this position and you have to break it into this new junction entity, normally, I'm giving you a hint, normally this is not an obvious physical entity. It's usually something abstract. Okay? So let's go back to this example and think about that. This tells me right here in the middle that we have an issue, right? So what do I need to do next to this little diagram I've got here? What do I have to do to it? Well, I have to probably do something like this to it, right? Okay, so what would that look like? It would look like this. I'd have, I'm going to take guest and room. That's many to many. And I'm going to instead turn it into the following. I'm going to say guest. We still keep these two. Room. And then instead of many to many, what we said we want to do is kind of put something in the middle and go like this. Right? And then we had to find out what that is. Yeah, so what is that? I heard booking. Is that the right answer? What does that mean? What's a booking? Reservation? Yeah, pretty close. Any other ideas? Yeah, I mean, per the discussion over here, that every time I check into this hotel, I'm not going to stay in the same physical room. That gave me a hint. Each time I check into a hotel, that is something. That's recorded as something, right? Yes, I heard booking, reservation, a stay can be another example, right? We can call it a stay. Okay, so yeah, let's call it, so since booking is more of just the act of booking a reservation, let's call this, just for sake of argument, a stay. And now each stay has a specific what? Reservation number, right? So if I call up the hotel and I say, hey, listen, I need to get my receipt from when I stayed there back in August, they can track that by not physical room. Like they don't ask you, oh yeah, I can send you your receipt for August. What room did you stay in? They don't. They say what? What's your reservation number? And then they can track it. So this is a unique attribute for this stay, right? Well, let's see if that makes sense. So now we say, okay, a guest can have multiple stays. Yep, I can stay at that hotel multiple times during the year. And for each stay, that's only mapped to one guest. Does that make sense? Yeah, that makes sense. Each stay, is tagged to one specific guest. It could be a family, it could be a corporation, but it's one guest. So that kind of makes sense. Now let's look at it this way. A room, like remember, this is physical room number 234, physical room. Can that have multiple stays? Yeah, that works. Okay, now, can a stay have multiple rooms? No. No. Any yeses out there? So what does that mean? A stay can have multiple rooms. That means when I stay at a hotel, is it possible that I can stay in multiple physical rooms? And you're saying no. And that might be right. You have to look at the business rules, the requirements. That might be right. There might be a policy that says when you check into a physical room, you can't change rooms during that stay. So in other words, if you go down to the desk in the middle of the night and you say, it's way too noisy by the elevator, I can't get any sleep, can you please move me to another room? They're going to say, nope, can't do that. No, but she just said, no, you can't do that. So if the air conditioning busts in your room and you go down and say, my air conditioning is broken, they're going to say, tough, you got to stay in that room. That's what the no response means, right? Or most hotels, if you go complain, they'll say they will allow you to change rooms, right? Now it's not normal, but they'll allow you to change rooms. So if that's the case, then I have to go like this, don't I? And if I have to go like that, then I have the same problem there in the middle again, don't I? So what do I have to do? I have to break it out again, right? So what I have to do is I have to go do something like this. I have to come back up here, and I have to say, okay, I have guest, I have stay, because we said that was okay, right? We said that was, and then we have this other thing, and then finally down here we have our room, and now we have to figure out, so I just added that other junction entity in the middle there, right? Okay, now what's that? Okay, well think about, okay, so if we're saying a stay, you can basically have multiple rooms. A physical room number can have multiple things. So what's that in there? Well, this is where it gets, again, a little bit tricky. Let me just throw out a name and just to move on a little bit here. But if this is room state, and what I mean by that is that room state can be, it can be booked, it can be occupied, it can be under repair, it can have multiple states, okay? So now this might work. A stay can have multiple rooms, and I can change rooms, and each room number can also be used multiple times, and that would actually make this thing work. Okay, but notice what I did. I started with this. I had to iterate and find something in the middle, which actually ended up being really good because now I know that I have to have something in my system that addresses this concept of a stay. Now, in the real world, in the physical real world, we know what a guest is. That's a person that you can reach out and touch. We know what a room is. I can read the number at the top of the door But what's a stay? What in my system, what does that become? What is that? You can almost visualize that as the receipt you get when you check out. It has all the information about your stay, right? Hold that thought. Let's come back to that. We have to ultimately understand what exactly does that mean. Okay, we also said something about services, right? Services is I'm just going to draw it out here right in the middle. I'm just going to go right like that. Services. What's services? So when I check into a hotel, I can use various hotel services, right? I can use internet. I can use parking, spa, all these things, restaurants. Okay. Now, does that services entity have a relationship to any of these other entities that we've already talked about? Yes? Which one would it apply to best? Stay? Okay, so, all right. So, that might make sense because each stay you have services, right? It would either be stay or guest, but let's say stay. What's the cardinality? If you have to just talk your way through it. You can look right at this and convince yourself. Okay, which way is the one and which way is the many? Stay. Okay, so this says, during my stay, I can have many of the hotel services. I can use Ethernet. I can use wireless. I can eat breakfast. I can make a phone call. Okay, that makes sense. So again, services might be things like internet, etc. Breakfast. But can I use internet on multiple stays? Yeah. Right? I have another problem. Right? So now what do I do? Well, I can break this up. Let me draw it over here. So here's my services. I kind of have, now I do something like this. So now what would that be? Okay, well here's what you can do. You can say, by the way, this iterative nature is perfectly normal. If you get into this and you have to do what I just did, kind of rip up this page, draw another one, that's exactly what you should be doing, because this is a discovery phase. And for requirements, the requirements engineer should be involved in trying to understand this well enough to understand hidden requirements. And I'll summarize in just a moment why that's important. So here's the deal. When I stay at a hotel, I can have many services. So this is like, think of this almost as the services rendered during a hotel stay, right? Now, that's the one-to-many, and then each list of services will apply to just one stay. So for example, let's go back to the checkout receipt. When you check out from the hotel, you get this receipt, right? And remember, and the guy says, here, will you please review this for accuracy, make sure everything's on here, right? And what does it usually have on here? It usually has things like the reservation number, right? It's got your name, address, blah, blah, and then it's got something like the hotel rate, the room rate, then like taxes. Then it somewhere in here in a chronological order, like day one, it'll have Ethernet or internet. I'm thinking of work too much. Internet, breakfast, and then it'll have day two, tax, and then so it's this chronological ordering of all the stuff you did, right? That receipt, this physical receipt when you check out, what up here does that correspond to? Basically, that this receipt that you get when you check out that shows everything you had during that stay is essentially this right here. Okay? All your stay information, all your services, right? What this thing is on the right, think of this also almost as this one-to-many over here. Think of this almost as the list of all the services offered. This can almost be something like a price list. So this just lists all the services and then which ones you're using for each stay. And then this will make that work. It might take a little while to figure that out. That's why I just gave you the answer. But okay, so what do we discover on this whole discussion? We have, if you're given a natural language description that might come from a customer that doesn't know a lot about modeling or things like that, what you do is you break that up into nouns, adjectives, and verbs. Nouns could give you an idea of which entities are important. Verbs show the relationships. Adjectives are the attributes. Then you try to understand, based on those verbs, where we have relationships. You draw the initial diagram. You have to show the cardinality next after you get the relationships. Once you do the cardinality, you have to convince yourself that that cardinality is right. And if you ever have any of these many-to-many relationships, you have to break that up into a junction entity. And there's usually something that you're missing in your thinking about how the system works. Most of the times people miss these is because they're more abstract entities, like a stay. You have to think about what those are, go back, add those in. Then, again, convince yourself again that the new cardinality is right. If not, break it out again, like we did here. Eventually, you'll be able to stop this iteration. And when you have this done, you're going to be able to have a better understanding of the different, like, what do we discuss during this cardinality discussion? We had this discussion on business rules. Should I be able to change rooms or not? That's a real important requirement to be able to flesh out early, right? And we just said, no, if the business rule was you can't change, then we would have made, this could have worked okay. But we said, no, we have to be able to support the guest changing rooms, so we had to come down here and do this. Same with the price list. So you find important hidden requirements when you go through this process. And even though we'll see this again, this is actually sometimes a very useful design artifact as well. It's a good approach to start early on. When there are jobs out there in the world today whose title is data architect. And some of these jobs, by the way, data architect, these are the guys that will go in, like from a consulting agency, they'll go into a company that needs help rebuilding their systems. And the first thing they'll do is they'll create an architecture of all their data. And that's a starting point to understand the system and how to change it. But just to give you an idea, some of these jobs make over $100,000 a year. So these are important, well-paying jobs as a data architect. So it's an important role when looking at IT systems for understanding requirements and things like that. Okay, so far so good on this? All right. One other concept. One other concept I want to introduce. Let's go back to the. I did all this on my notes, but in your class notes, this section, it takes you through all this. So there's your entity, attributes, and relationships. There's the different cardinalities. There's how to create the junction entity with another little example. There's the hotel reservation system we just did, and that's the thing I just drew. Okay? It's all there in your notes. Now, when you have this, you can, not only is this good for discovering requirements, which is our primary intention at this point in time, for the system. It's also a good way of also beginning to understand the user interface requirements. Now, the user interface has, like I mentioned earlier in the course, it's really difficult to understand the requirements for a user interface without at least sketching something, okay? And so once you have this, you can also, instead of just stopping and saying, okay, I have some pretty good understanding, I can go build my system or my requirements document now. You can also use this to flesh out an interface. When you're building an interface, and as you can see in this sample interface here, I've got this little window, and I've got it called stay, which you can argue is stay right here. In that window, there might be a payment method and some other information, which you can also add into the stay window. But also, what else is in this stay window? Not just stay number, like this, like stay ID. But what else is in there? Well, there's guest information in there as well, isn't there? Now, where does guest show up? Well, that's interesting. Guest had this tight relationship with stay. Okay, so now we're saying that this one window has information about the stay and the guest. Well, actually, it also has some information about the services, which, the stay also has a nice tight relationship here too, right? So what's the point behind all this? Notice that the service prices, by the way, the service prices out here is kind of like this thing out here, okay? This rooms information here, separate, is more like this, okay? So what are we seeing in this set of very high level, I call them virtual windows. I call them virtual windows because if you look at this like stay, what's obviously missing here? You don't see any real widgets, right? You don't see like any command buttons or menus or, user interface widgets per se. It's just like a box that's formatted with information, right? So a virtual window is taking the data from the ERD and partitioning it into different user interface views, okay? Now, hang on a second. Now, here's the important point. When you're creating your user interface, well, let me before I do that, let me jump to this again. If you have a system that has information about, like I showed you here, so we have all this information like I just drew. All this is going to make up some database that your system is going to store all this information, right? Now, if I put information into this database, let me go back to this previous example about the data flows. Remember I made the comment, if there's information in these databases, this data store right here, this is the equivalent of this, right? So if there's information here, remember I asked the question, shouldn't there be a way of getting some interface to the user to write, or in this case, read data from those data stores, right? That makes sense? So if I have this hotel reservation system, a database, and this is the structure of that database, would you agree with me that there's probably a need to be able to have some interface that provides the user access to this data, right? So for example, a guest walks in and wants to check in. What does the hotel reservation agent have to do? It has to be able to pull up something and allow the guest, and to type in the guest information, right? Can I see your passport, please? Type in the information or scan it. Any way you enter it, doesn't matter. So I have to have a way of entering guest information, right? Do I have to have a way of entering services, right? So if I go eat breakfast, what happens when you go into a hotel, into some hotels, and you go in to eat breakfast into the dining room? What do they say? Can I have your room number, please? Then they go take your room number and they go in and they have to enter it into a system somewhere so that when you check out, they know that you have to pay for breakfast that you just ate. So you have to be able to enter information on that, right? The price list, do you think as a hotel reservation agent, I should be able to pull up and view a price list? So if someone says, how much is internet per day? And I can pull up the price list and tell them, yes? How about, should I, if someone walks in off the, or a guest comes in and says, hey, can you give me a room with an ocean view? And you say, okay, yeah, I can do that. And you have to pull up a map of the room so you can tell them which one is it. So do you think there might be a need to view room information? Okay, well you can probably answer yes to every one of these, right? Either someone wants to view it or someone wants to write it, create one. Okay, well in IT systems, I'll make an argument that all this right here in this ERD, which all goes into this database, we need to somehow manifest some of that in the user interface in some way, right? Okay. Now, when you're doing that, the common term I like to use for all this is the term you're probably used to called credo, right? If you're not familiar with this, what it says is for every piece of data, you have to determine somewhere in your system, where is that data? Where do you create it? Like, where do I create a new guest? Where do I have to read information about that guest? Where do I edit information? Where do I delete information? And where do I overview information about those different pieces of data? So for a guest, okay, let's take one piece of data, guest. Somewhere in my system, do you think I have to be able to create a new guest? Yeah, someone walks in, I'm brand new, never stayed in a hotel before. I have to be able to create a new guest record, right? Do you think anywhere in my hotel reservation system I should be able to read information about a guest? Yeah. Do you think I should have to edit information about a guest? Yeah. Hey, I changed my phone number. Let me give you my new phone number. Okay. Well, should I ever need to be able to delete a guest record? Probably, right? I mean, once I check into a hotel, should they keep a copy of my information forever? Or maybe after a year of not staying there, your record is automatically deleted? Something like that. Overview. Overview means, is there a requirement to be able to look at all guest information? Overview, think all. So for example, let's say I have a hotel, and my hotel has a hallway and an elevator, and then I have all these rooms, right, on the hall. All these rooms, right? That's an overview, a way of viewing all the information about rooms. Okay? So do I need the capability of being able to overview or see information about all of my guests? I don't know, maybe, maybe not. Definitely I can see it being the case for like rooms. You want to overview all the rooms, in the hotel. Maybe not for everything. This is usually optional. Okay? So, all right, so hopefully I've convinced you that for most of the information in an ERD, the user has to be able to do actions on that object: create, read, edit, delete, overview. And where do I do these from? Some interface, right? So if you go back to this guy, what I'm trying to show here is, okay, since we just convinced ourselves that I have to be able to, example for guests, I have to be able to create a new record or edit it or maybe even delete it or what have you. This down here is almost an example of an overview of rooms. You can see over time, you can see an overview of which ones are occupied and booked. This is almost an example of a overview function. But you have to be able to take that information from the ERD and map it into this virtual window, right? And notice how, let's look at, if I counted the number of windows here, it's like 1, 2, 3, 4. is part of that one. So 4. And let's go back and look at how many entities in this ERD? 1, 2, 3, 4, 5, 6. Well, that actually makes sense. The number of virtual windows, the number of interface windows should actually be less than the number of entities. So in this particular case, I have stay, guest, services, all in one. This is important because if you put a window on top of every entity separately, that's referred to as viewing data through a straw. That means I'm constantly having to shift windows to see every other little piece of data. It's usually not a good idea. So usually the amount of windows is less than the total number of entities. In this case, we had 4, which is less than 6. Okay. Make sense? Okay. So once you have some of these things, these models we've been building up, you can also do a pretty good job at kind of beginning to validate them with each other. So here's a case where I create an ERD. Again, I discovered some hidden requirements, and I can create some virtual windows, which again think of it as user interface requirements. Now the first thing I've done is I've just put this data, I've just put it in containers. And I formatted it a little bit, but I haven't really fleshed out the interface yet. And earlier, remember, we created these use case scenarios. So now would be a great way of taking the data model, make sure that all the data in the data model, excuse me, is somewhere in one of these virtual windows. Then walk yourself through a use case scenario and make sure that, like, for example, check in or do a booking, make sure that your use case scenario can be supported by this. If it can't, you probably have a defect and you can document that. Okay? So when you start to collect these models like we've been talking about, use cases, sequence diagrams, activity diagrams, state machines, virtual windows, you can literally begin to check them to make sure that they're self-consistent. In other words, if you're saying I can do a use case scenario, but I can't support it with what I did up here, then you probably did one of them wrong. Okay? So you can do that kind of work. Okay? Talked about this already. I showed you the picture. This case study we were developing software that ran on a cell phone. This blue box, think of this as a cell phone. We did this for Motorola. And we were able to pull out debug and trace information and display it in a desktop computer. And we were supposed to, the customer wanted certain data. They wanted to see all the source lines of code in the interface, the C code. They wanted to see the assembly language. Now, obviously when you compile C code, you get many lines of assembly code, right? So that's that relationship, source code, assembly code. And every line of assembly code, they wanted to see certain debug messages that happened during that execution of that assembly code. So we have C source line, line number, assembly code with an address in memory, and then one or more debug messages with a message indicator, message type. So that's what the ERD looked like, right? They told us to go off and build this. This is a real life thing. This is what I experienced when I first came into the role I'm in. We went and built an interface, and we built an Eclipse-based interface, and it looked really cool. And we got it all working. You can see, in this case, well, it's kind of hard to see, but here's the source code, the C lines. Here's the assembly code. Here's the debug messages, right? We shipped this to Motorola up in Chicago, and we started getting hate mail. They hated it. Now this is a big customer, and they're so big that we give them these tools for free. But they came back and said they'd rather spend $30,000 of their own money on our competitor's product, tools product, instead of ours that we were giving away for free. What did they not like about this? I mean, after all, this is a nice polished Eclipse GUI. What's wrong with this? Well, it's kind of a human factors issue, but what we did in the ERD is we put a different interface on top of every entity. What I just got through saying was wrong in that other example, kind of like viewing data through a straw. What does that mean? What did I do? What's wrong here? Let me give you a hint. When you focus on a certain area of an interface, the way your eyes are designed, when you focus, you can focus into just a few centimeters of area, and everything else goes into your periphery, which is very rapidly decays into blurs, right? You can detect good motion out there, but you can't see anything of any accuracy. So if I'm staring at this, what's my problem? Yeah, if I want to correlate, if I want to know, like, for example, this assembly line of code, where's this C line of code, what assembly lines of code? I have to jump down here. And what debug messages did that produce? Well, I got to jump up here, okay? So you're jumping all around. It's very difficult to correlate. That's what's going on. Now, our competitor, which I ended up getting a screenshot from because I was involved in this, trying to fix this problem, they did it right. So again, keep in mind, C, source code, assembly code, debug messages. Here's what our competitor did. Look down here. Here's the C code. Right underneath it, assembly line of code. Right underneath it, debug messages. Now, if I focus on that 2 to 3 centimeter area, what do I see? I see everything, right? As opposed to jumping around. So they did this, they did that. They integrated into one view. And why did they integrate all this? Because these strong relationships made them do it. So they didn't have to jump all around. We did that. So you got to jump here, jump here, jump here. From a human factors user interface perspective, it's terrible, and they hated it because they couldn't track anything. So that's an example of that's an example of how the data model is important for finding requirements, granted, but it's also really important for helping design an interface. And you can build this right into your prototype and get some early feedback so that you can begin to address these problems sooner rather than later. Okay? We already talked about state machines. Questions on any of that? So we're gonna stop there. Now, there's a couple other modeling approaches we didn't talk about. We're going to talk about something called the Petri net. We're going to talk about a couple others coming up. We'll get to that probably after the midterm. So now you know what's going to be on the midterm. Okay, so the midterm is going to contain everything up through what we just covered. Okay, so what does that include? Really, if you pull up the notes, we can go through it real quick, but it's basically everything we kind of covered in the notes. We talked about just early introductory stuff, but again, be familiar with all these concepts because there's going to be a series of these multiple choice questions that'll touch on this, but I'm just going to flying through it quickly just to so you remind you what we did. So we talked about that. We talked about process, constraints, system constraints, functional and non-functional requirements, right? We spent a lot of time on that. We talked about, this is still non-functional. A few other categories of requirements. This is just, again, fill out other classes that people refer to, mutable, emergent. This is probably not something you're going to have to worry about. Timing requirements was another form of non-functional. Safety critical requirements, we had a homework on that, right? Okay, so that section, we did a fault tree. All the safety, we spent a good lecture on this. Wicked problems, we talked a little bit about. I just gave you one example of that. Open metric, open target, and quantifiable requirement. Remember, a non-functional requirement, it's got to be quantifiable, measurable. Don't tell me it's got to be fast. Tell me how fast, that type of thing. In some cases, you may not be able to, or you don't want to specify. You want your vendor to help you specify the target, so you can use this open metric, open target approach. We talked about other forms of non-functional: capacity, accuracy, performance, psychological, or user interface, usability, security. All these were different types of, remember, we walked through all the different classes of requirement types. I'm not going to make you know the details of every one of them, but just be familiar with, if I was to ask you to give me an example of a security requirement, you should be able to at least tell me the basic, type of security requirement. We talked about frame diagrams, right? Remember the 4-variable model? We went into problem framing, right? Yeah, you'll probably get I know this was the difficult one. Remember, just to grasp the concept. So what was the key thing about frame diagrams? It was, you have to have a domain of interest, a machine domain. There's probably always going to be one or more connection domains, and every connection domain adds an upper limit on how well you can do, primarily by introducing distortion and delay, and you have to be able to understand what that is. I haven't decided whether I'd give you one of those, but you did a homework on it. Be familiar with that frame diagram. Talk through all that. We talked about process models. Be familiar with these. We talked about use cases. Okay, requirements. A little bit about requirements management. And then we get into. I'm not going to make you understand. Well, we didn't talk a whole lot about ISO 9000 and CMMI. Just be. I'm not going to make you know all the levels. Yeah, don't worry about that. I'm not going to grill you on that. Different sources of requirements. Going through them very quickly. We talked about different elicitation techniques. Just be familiar with the ones that we talked about in the notes. We talked about use cases and scenarios. You'll definitely have something on this. We talked about the template earlier tonight. We're almost done. Storyboards, I mentioned that to you tonight. Misuse cases. Understand the concepts behind this. Basically, all I'm doing is just going through all the charts we already talked about. I'm just doing a quick summary for you. And then tonight, which was prioritization. In the lecture, I wasn't here. It was all about state machines, sequence diagrams, activity diagrams. And then tonight, it was about essentially data flow diagrams in ERD. And then we stopped. Yeah, the virtual window, excuse me. And that was the end. So basically up through, if you throw in state machines, which we talked about, although I think about knowing up through there, 261. That's the material we've covered, plus the video lecture, we had, right? That's about where we stopped. So if you do the following, if you go back to the notes, just understand the concepts up through that where we are, almost halfway. Look at the homeworks and the sample solutions. If you've got any questions on what I post for a sample solution, let me know. Ask me questions. But the homeworks, the notes, that's going to be the midterm. Again, the midterm, if you came in late, there'll be a set of multiple choice. There'll be several short answers, and then I'm going to give you at least 3 different modeling approaches. You can almost guarantee I'll give you a use case / misuse case, the use case diagram scenario. You'll get probably out of the modeling techniques, data flow diagram, entity relationship diagram, and state machine, you'll probably get at least 2 of those to do out of the 3, depending on how much time we have. I got to look at how many questions I'm going to have. But know them all, right? But you'll get probably at least 2 of those, right? And then, again, depending on just how much time, I haven't decided on whether a frame diagram sometimes takes a while to think through that. We'll see whether I may skip that one. I haven't decided yet. Closed book, closed notes, let's try that for the midterm. You have the whole class to do it. Bring some, a few sheets of extra paper if you need it. I do look at work, so, anytime you can put down a comment or an assumption, hey, listen, here's what I was thinking when I developed this diagram, that'll help me understand the context, all that's useful stuff. And given that we got 2 weeks, catch up on the homework if you still need to do that. I'll make sure I do my part and get them all graded and give you plenty of time to study for the midterm, okay? And then thanks for reminding me, because otherwise I would have driven all the way up here next Tuesday that we did not have class. Otherwise I would have been really, really upset if I had to do that. So thank you very much for mentioning that to me. Any questions before we wrap up? Here are all the notes for today. Yeah. Yeah, good point. You know what I'm going to do? The 6 is the last one out there, right? Yeah. I'm going to post a homework 7. Let's do this. Let's make homework 6 and do like the end of next week. And then homework 7, which will be on the material from tonight, I'm going to make that essentially due the week after. Now, if you turn it in early, like before the midterm, which is that Tuesday, then you'll get a chance to look at a sample solution. You can use it as a study aid. If you don't, no penalty either way, but if you do, it could be an opportunity to, because the homework for tonight, you'll definitely see at least one of these on the midterm. So it's up to you whether you want to try it and get some feedback or not. So, did you have a question? Exam is in class. Yeah. I think, you probably don't want to bring your computer. That would give you a significant unfair advantage. So yeah, just show up with a pencil or pen and your smile, you're ready to go, and things should be fine. Other questions? Okay, so I'm not going to see you then actually for 3 weeks. Next week we're off. The midterms can be proctored. That's the other week I'm going to be in Europe, so that's why we're going to do it on the 21st. So that'll be proctored, and then the week after that we'll be back together live, right? So that's enjoy your break, and we'll talk when we see each other again. So, all right, thanks.
Can you ask them that more?
On what now?
Can you ask them that more?
Yeah.